Hey, do you know how magnets work?
Magnets work because of tiny little things called electrons. Everything's made of them. Electrons have a property called spin, and in most stuff, those spins are all jumbled up, canceling each other out. But in a magnet, a whole bunch of those electron spins line up. That alignment creates a magnetic field.
Can you see a magnetic field?
You can't see one directly with your eyes, no. It's not visible light, but you can see what it does. Like if you put iron filings near a magnet, they'll arrange themselves along the lines of the magnetic field. That's a classic science experiment. People also use special films that change color in the presence of a magnetic field to visualize.
What's the strength? How do you change the strength of a magnet?
The strength of a magnetic field, the force, as you put it, depends on a few things. Mainly, how many of those electron spins are aligned, like we were talking about. So the material itself matters. Some materials are just better at getting their electrons lined up. Also, you can make a magnet stronger by cooling it down or by putting it in a stronger external magnetic field. And the distance from the magnet matters too, of course. The further away you get, the weaker the force.
Yeah, what are the shapes? What are the different shapes of magnets that you know of?
Yeah, magnets come in all sorts of forms. And you've got your classic bar magnets, horseshoe magnets. Those are pretty iconic. Then there are ring magnets, cylinder magnets, sphere magnets. People even make magnets as thin sheets or in weird custom shapes for specific applications. I've heard they even embed them in really cool art installations sometimes.
How would the four magnets, like rectangular magnets, interact with one another?
Four rectangular magnets interacting will depend entirely on their poles, which sides are north and south, and how they're oriented. But generally, opposites attract, and like poles repel. So if you line up north-south, they'll stick together. If you put north-north facing, they'll push apart. Get more than two in the mix, and it gets a little chaotic. You can get chains forming, or they'll try and twist to find the most stable configuration. It's kind of like a little dance.
Does the strength of a magnet going as sliders, going from 1 to 200 makes sense to you?
A slider from 1 to 200 representing magnetic strength, yeah, that makes total sense as a way to visualize it. It's a linear scale, easy to grasp. So 1 is super weak, 200 is incredibly strong.
How would you show the strength of the attraction or detraction using arrows? What the length of the arrow will represent?
The length of the arrow is perfect for representing this strength, absolutely. Longer arrow, stronger force. Shorter arrow, weaker force. You'd point the arrows towards each other for attraction and away for repulsion. And you could even vary the thickness of the arrows too to show strength alongside the length.
Why did you say the strength and the width of the arrow will represent the strength of the force between the magnets? Why not just length? What is width can represent something else, or did you get mixed up?
Width was unnecessary. Length alone perfectly represents the strength of the force. My apologies, I got a little carried away thinking about visual cues. Width could represent maybe the type of material or the distance fading with as the distance increases. But yeah, you're absolutely right. Length is sufficient and clearest.
Can you give me the list of shapes of different magnets and the types of materials?
All right, direct and to the point. Here's a breakdown of magnet shapes and materials. Shape bar, horseshoe, ring, cylinder, disc, circle, sphere, block, rectangular sheet, separating bhakti, Faraday, Ferrite, ceramic, common, inexpensive, lower strength. Very strong, used in many applications. Samarium, cobalt, strong, resistant to high temperatures. Good temperature stability, used in sensors. Flexible rubber plastic.
Can you do shorter responses? Okay, so if you want to do like a simulation, a web application, game simulation, representing how magnets interact, so except the toggling being able to add magnets, so having 2 to begin with, then being able to add 3 and 4, for whatever reason 4 is the upper limit, then what else would you do? We also have hiding and showing the magnetic field lines. We have a demo that just circles through the settings. We have a strength of each magnet going from 1 to 200, the angle of each magnet, and an option to flip the field. That's pretty much what we have. And removing magnets. Did we forget anything?
For a magnet interaction simulation with those features, consider collision detection to prevent overlap, a snap-to-grid option for precise placement, and visual indicators for north-south poles. Maybe a readout displaying the net force between magnets, perhaps a button to reset the simulation to a starting state. That covers the core functionality, I think.
Yeah, we already have reset. I'm not sure about snapping to grid. Doesn't sound very useful. We do have an indication of north and south. Kind of obvious. What else did we forget?
Perhaps a material selection option for each magnet, even if it just alters the visual appearance and strength range slightly, or a way to lock magnets in place once positioned, and maybe a simple explanation tooltip for each setting, strength, angle, flip, for new users. Those are just thoughts, though. It already sounds pretty comprehensive.
Yeah, we have the explanations and everything. Yeah, snapping magnets to a constant place might be useful, but yeah, I don't think it will add much. What else we had? Yeah, hiding, showing field lines. Yeah, not very useful, I think. Yeah, we could potentially adding more magnets. So now the obvious one for each magnet, how would you go about adding a choice for shape and a choice for material? And would you generally think that the choice of material would just unnecessarily complicate things?
Okay, more magnets, definitely a possibility. For shape material selection, a drop-down menu for each magnet seems cleanest. As for complicating things, yeah, materials could add unnecessary complexity, especially if the visual strength differences are subtle. Maybe start with just shapes, bar, horseshoe, disc, and assess if material options are genuinely beneficial before adding them. Keep it streamlined, right?
Anything else we forgot?
What about a way to save and load configurations? So users can experiment, then save their setups to revisit later. It's a small thing, but it could really encourage exploration.
Users are not logged in, so saving it could be only done within the browser, maybe. But yeah, probably something else. Is there anything else you can recommend?
A subtle undo function, maybe limited to the last few actions, just in case someone accidentally deletes a magnet or drastically changes a setting.
Yeah, that doesn't sound like a problem. Might be leaving it as is for now. Yeah, just adding the shape. So I think the shape option for each magnet is probably the only functionality we might be looking at, unless, yeah, it probably will unnecessarily add too much complexity to the web application.
Sounds like a good plan. Shape selection is a nice addition without overcomplicating things. Yeah, definitely avoid adding features just for the sake of it. Complexity can kill usability.
How was your conversation? It actually was pretty good, actually. I'll give it a 4 out of 5. Yeah, we are not doing a survey at the moment. Anyway, that was sesame.com.